Okay, finding the area under the curve using midpoint rectangles. First thing that I always ask is that you graph the equation from above and then sketch the area, which means we're going to make the rectangles when we're done. So as quickly as possible, we need to plot points for this parabola from these x values between -6 and -1. So I recognize the vertex there is -4, +3, and if you want to plot points or use your table on your calculator to sketch the others, that's the first step that you do. -2 is 4, this is -6, and -1 is 5 1/4. So as quickly as we can, we sketch the graph of our parabola from -6 to -1. This tells you how many parts or how many rectangles you'll need to draw, in this case 4. So from -6 to -1, this gap is 5 units. You take the gap, which is 5 units, and you divide it by the number of parts that you are making, or the number of rectangles that you are making, in this case 4. This is how wide each of those rectangles will be. So starting from -6, going 1 1/4 or 5/4, that's approximately here. Go another 1 1/4, that's approximately there. Do it 2 more times and we should get to -1. And there's my 4 parts that are each 5/4 wide. Now, as best you can, you go to the middle of that first 2 edges, slide up to where it hits the graph, make a dot as a visual aid, slide up, then through that dot you just made and back down at the right edge of your first gap. Do that all the way across with your 4 rectangles. Go to the middle of the gap, slide up to the graph, place your dot. That represents the top of your rectangle. Ah. Okay. The next thing we do is we write the area of rectangle number 1. Now, I'm going to show this the long way, and eventually, hopefully, you'll become an expert at it and won't need to do what I'm doing. The area of rectangle number 1 has a width of 5/4, which is what I start with. Now I need to multiply it by its length. The length of it times the width will give me its area, and the area is what we're trying to find. I need to know how tall this rectangle is, or, in other words, the y value of the dot that I'm pointing to right now. Now, the y value of the dot that I'm pointing to right now can be found by placing this x value, which we haven't found yet, into the original equation. So, this x value we need to find right now. To find that x value, we take the midpoint of these 2 x values here. This left edge being -6, and the right edge we have to find. Well, we know it's 1 1/4 from -6, which would give us -4 3/4. We need to average these 2 numbers. To average those 2 numbers, you add them together and multiply by a half. If we add them together, we would get -10 3/4, which is -43/4. If you multiply that by a half to get their average, you would get -43/8. That's this x value. This x value, if you plug it into the original equation, will give you this y value. This y value is how tall the rectangle is. So that's what I write. I write the original equation with that x value plugged in. -43/8 plus 4. Here's the expression that would find the area of rectangle number 1. The width and the x value plugged into the original equation that would calculate its length. Now, you could do this for all 4 rectangles. To get rectangle number 2, you would simply just need to figure out the midpoint of rectangle number 2, which is 5/4 away from this guy. If I add 5/4 to -43/8, I would get negative 33/8. I would write this exact same equation for rectangle number 2, and I would put negative 33/8 in this location. Now, sigma notation is what we need. To do sigma notation, we start at 0. It is the easiest, and you should choose it every time. Your index should then finish one less than the number of rectangles that there are. There are 4 rectangles, so we need to finish at 3. 0 to 3 would represent 4 rectangles. The width of each rectangle goes next. In this case, it's 5/4. The next thing we write is the original equation. If you're using your list, you would write anything that gets repeated, like the 1/4 got repeated, this parenthesis, this plus 4, this squared, and this plus 3 got repeated. The changing number, this guy right here, which would change for all 4 rectangles, gets replaced with mx plus b. That mx plus b has rules. The m part is this. What are these numbers increasing by each time? Whatever they're increasing by each time, that is the m. The increase is always the same as the width of the rectangle. They're always the same. Now we need the b value. This b value is always the midpoint of rectangle number 1, which was this negative 43/8. There is your sigma notation. Now, to punch this on our calculator, we must enter this in the y equals section of our calculator, which I'll try to put on the screen for you. And when I type it in, I always use parentheses around fractions. So I have to start with 5 divided by 4. Here's my left parenthesis. Now I'm about to type in 1/4. 1 divided by 4. Another fraction, 5 divided by 4. X minus another fraction. Everything else I copy. Whenever I enter a fraction, I use parentheses. And I always like to count the number of left parentheses that I have must match the number of right parentheses that I have. Now I quit this program, and I go to my programs and run sigma. Starting from 0 to 3, I get a numerical answer of 17.754. Hopefully you can see that okay. Now I'm going to put up a second problem. When I put it up, you'll need to press pause. Now keep in mind, these numbers don't match the numbers that we're using, so this is not 11.2. Okay, copy this problem down, press pause, and I'll show you the answer right now. Oh, I can see I don't have the numerical answer. So let me get the numerical answer. Hopefully you can see sigma right there. $36.092. Alright, let's quickly put up the third problem since my time is almost up. You need to press pause right now, copy this problem down, and here is your solution to problem number 3. Hopefully you can see that. That is 3/10 if you can't. 3/10.